Hello, everyone. I am sorry that I will not be able to be with you this morning because I have to rush down to the airport so that I don't miss my flight. I mean, it was changed, so that's actually screwed up the plan to be with you this morning. So I'm going to quickly go through what we did yesterday, just to give you a recap of the last part of what we did, which was to solve the SIR model, this problem here, and then also fit the data to the experimental data that we have on the chart. So to make things easy, I have expanded this table to include the slope so that we can calculate the slope first and then calculate the updated values of the SIR. So first thing is that the initial number of people that are susceptible. Here, we are starting with the initial number of people that are infected, and then that is 1. And the initial number of people that are susceptible is going to be the total number of people within the community minus, minus the initial number of people that are infected. So that's going to be equal to n, we've labeled that, minus this I. So y this guy is 0. So then we start calculating the slope. So the slope of S, according to this equation, is equal to minus beta times times I, then times S divided by N. Enter. And then we can use autofill. Then we go to I. So for I, that's equal to beta times I times S divided by N, then minus gamma times I. So there's a problem there. All right, so it's not I. What I'm supposed to use is cell. All right. Then for R, that equals gamma times. So let us also fill this. And let us fill this one too. All right. Then I then need to calculate the new values of S, the new values of I, the new values of R. To do that, I'm just going to apply the Euler method, which is equal to the old value plus the time step times the slope. All right. And then for the time step, I can just, in this right here, I can just fix the C so that I can drag it. I can do autofill to the right. So I don't have to repeat for I and R. I just copy. So let me fix the C. And then for this, I will just, and then it updates the I and the R. And then to fill it down, I just double click this so that's just and that is it. So, of course, I have added S and the R to the plot, but we're interested in I, so let me pick them out. And so that we can just focus on the I. So that is the I that we just calculated here, the orange line. And then this is the experimental data. So again, we can then come here and say, okay, let us then fit this data. How do we fit it? The first thing we'll do is to say, take the difference between the experimental value and the predicted value. So that is equal to the experimental value minus the predicted value. And then set the value. The next thing is to come in and compute the SSE, because that is the sum SQ of everything that you have in this column. It's 44,994. Then we proceed to use the solver. So what do we do there? We go to data, and then we click the solver. Then I have this already selected. So this is my objective function value, right? So that is I2 SSE. And then I want to minimize. And my decision of variables is C2 to E2. And the next thing is to click solve. I click solution. This is it. We are done. With this, we have the correct value of beta, gamma, and hence 348. Thank you for listening. You can practice, then you can do your the host test. Thank you.